Oh, and since it's on the negative side of the starting point, then that would make it a negative number, right?
Yes, absolutely.
And yeah, and I had the 2.185, but why do you, like, I'm confused on where you got the 6.2.
There's two answers, one where you add and one where you subtract. So once you get this, which way, I think it's what, 41.41?
Yeah, that's.
So you get 20 plus 41.41 divided by 9.8, and then 20 minus 41.41 divided by 9.8.
Okay, because of the plus minus thing, right?
Yes.
Okay.
No other questions? Now, when we did this before, when we had the problem in it, when we had displacement is positive, we had 20 plus or minus the square root of, was it negative 9 something, 917? We'll pretend that was it.
Yeah.
When you get a negative under the radical, your options, the problem's not possible. That's why we went through the exercise. If I throw an object in the air, is it possible for it to land below where it started? Yes. So the negative under the radical, again, either means the problem can't be done or there's a mistake somewhere. What you are not to do is go, oh, negative under the radical, let me just get rid of that. Okay, now we can do it. Negative under the radical is a warning sign. It's a red flag saying something's off. The number of times I've seen people just get rid of the negative sign because it's inconvenient, it's very frustrating. But this will be the group that doesn't do that. No one in here is going to get rid of the negative sign just because it's inconvenient.
Correct.
Excellent. And I will sing songs about this group forever. Put it on YouTube, and that way it will be around forever.
Why was the displacement positive in the first question?
Oh, because when we dropped it, because somebody established, I think Ray or Ian established that down was positive.
Yeah.
And in this
He
case, up is
said down
positive.
is positive, that's right.
Just neglected to say it's negative.
Yeah, well, the acceleration is downwards. Acceleration of gravity is always going to be downwards. Displacement in this case, since it ends up lower than where it started, displacement is also downwards. So these two have to be the same sign, whichever way you're doing it.
So we solved for, we used the third one, so we got that 2.18 and the 6.266, but that would be the final velocity, right?
These,
Yeah.
those are the times.
Why would that be times if we use the equation that solved for the final velocity?
This is the equation we were using right here.
Oh, the fourth one. So then,
We used the third one to figure out how fast it was going, but the fourth one to figure out the time.
but that equation equals the displacement, so how did we get the second, like, I don't know.
Because whenever you're solving any of these, you've got the 3 bits of knowledge that you know, and then you figure out what you're trying to find. In this case right here, how long, I really should do how much time. I had a student who still spoke with a heavy accent, or she knew English, but still spoke with a heavy accent. She was an adult when she came to the US. But every time she saw the word long, she was thinking distance and not time. So how much time does it take? I don't know if that throws anyone off in here, but it's probably gonna be a while before I break myself of the how long. But how much time does it take to hit the ground? So that's what we're trying to find. These are the 3 things that we know. So VF, we don't care about yet.
Okay, but what I'm asking is like, so that fourth one, that equation equals the displacement, right?
It does, the displacement is equal to this, however, it also, we know 3 of the variables in here, and we're trying to find the 4th one. Once you have established the 3 that you know and what you're trying to find, you are looking for the equation that does not have the one you're missing.
Okay, okay.
So we don't care about VF, we're not looking for VF, so I want the equation that does not have VF in it. It's this one. And by the way, on master sets or tests or anything like that, I mean, often a problem like this, I'll do in multiple steps. I think the most number of steps I have in any problem, I think I got through parts A through P. Generally, I present them in the order in which I do the problems. If you need to do them in outside of order, we don't necessarily have to do this. There are multiple ways of solving it. If you need to do part C in order to do part B, then do part C first and then draw an arrow saying, I use this in order to find part B. I'm fine with that. I have seen students do part C based on information they have in part B, and do part B based on information they have in part C. So it's this circular argument here. That doesn't work. Right? I generally mark one of them wrong and one of them right.
Yeah, you shouldn't use something you calculated unless you have to. Stay with the knowns or the given.
Or they made up a value for one of them. It was hard to, sometimes it's hard to tell what the thinking was. But they ended up with this circular logic. Not throwing stones in that glass house, but. Oh, now let's suppose that you have very bad traumatic childhood scars from the quadratic formula. It is possible to solve this without using the quadratic formula. So, how to solve it without the quadratic formula? Obviously, that's the quadratic formula here. There are times I've actually given it where it can be factored perfectly and you don't have to use the quadratic formula, but that's not what I'm talking about. I'm saying avoiding the quadratic here. First thing you do is you actually solve for this one first. So if I wanted to solve for VF, which equation would I use? Assuming we do not know time.
Second one,
Okay? So VF squared is equal to 20 squared plus 2 times negative 9.8 times negative 67.081. And so, if someone would be kind enough, preferably more than one, just so we can support for whatever answer. Jacob, you look like you have an answer?
Yeah, 1,714.
Oh, is that before the square root?
Yes.
Yeah, before.
Okay. So you have,
Oh.
square is 1,000, what is it?
1,714.7876. Square root that.
41.40999. There's one more 9.
All right. When doing it this way, though, we have to do one more step. I mean, not just solving for time.
No, wait a minute. Don't you automatically get a plus or minus situation when you apply the radical?
Yeah.
So technically, you're doing it twice, you end up with 4 answers instead of 2.
But one of them makes sense. Technically, it's positive or negative 41.40999. which one of these answers, well, actually,
Cause the power of two automatically gives you two solutions.
technically,
That's what I remember.
yeah, no, you're right. Technically, what is this number right here, if we threw in meters per second afterwards? What is that telling us? More specifically,
That's going up.
I heard here, oh,
It's going up.
no, it is a scalar. Isaac, what is this?
It's speed?
Speed. This tells us the speed. This is speed here.
Right.
My speed is positive. But to use the other equations, I need to know velocity. Mathematically, yes, there is a plus or minus involved there. But you need to think about, in the problem, I throw the ball up, I'm trying to figure out what it's doing right before it hits the ground. My final velocity is negative 41.40999. Now I can use one of the other equations. Probably the third one is the simplest. So I have negative 41.40999 is equal to 20 minus 9.8 t. And I'm feeling somewhere around 6.266. So in a problem like that, the choice is yours. You could do the quadratic formula, get two answers, go, all right, the positive one is the one that makes physical sense. Or do it this way, remembering to put in the direction to find the final velocity, because we have the speed over there, and then solve for it that way. You know, whichever way your mind is working at that moment. And at this, right.
Okay, that's the first one. It's all right. Trying to figure, which formula did you use for that last
For this,
tidbit?
using this, the VF equals VI plus AT.
Okay.
I could have used this one as well. That one doesn't have time in it, so that wouldn't make sense.
First one, friendlier.
Okay. Whichever way your mind's working at that moment.
So the only thing we're doing to go from speed back to the final velocity is just changing the sign based on whatever you decided was positive and negative, that's all.
And the physical situation of the problem. Yeah. All right, here we go. Nah, I'm not gonna bother doing that. All right. I'm gonna officially declare chapter 2 done from my point of view. Which means, where's the master set? Today is the 13th? Yes. How's the quiz on Friday sound?
Okay.
And then the master set, due on Monday the 20th. All right, master set, I guess this is the first master set we've done. If you go on to Blackboard, under coursework, chapter 2, eventually after the textbook homework problems, you'll see something called master set 2. I think it's something clever like that.
Yeah.
That you would open up, print it out, like, I guess you don't have to print it out. Questions to answer, all related to chapter 2 stuff. And joy was had by all.
No? Is that something we're gonna turn in?
Yes, and that is something that you turn in. The master set is to be turned in.
The chapter 2 master set,
A week from today.
you want it next, Monday a week?
Yes. And while you are processing this information, I need. You know,
Friday's quiz is homework, right?
yep, I'm gonna take 2 of the homework problems. Change the numbers, 2 of the assigned homework problems, change the numbers. And present it back to you, call it a quiz.
Okay.
I need a clamp. I'm just using it for the stand, I'm not using it for the tube. So what I'm gonna do is I'm going to drop and project a ball at the same time. There we go. So when I flip the switch, the rod is gonna, there's a spring in there, the rod's gonna shoot that way, which is gonna basically yank this out from this ball right here, so the ball will fall close to straight down. This ball is gonna get shot that way. So the question is, which one will hit the ground first? So let's try voting by, physics by democracy. So we have the ball going straight down, the ball being shot out, and then all right, so there's the ball that's going straight down, the sad marker. Ball that's going straight down, the ball that's being shot out, tie, and then neither is that one of them will burst into flames and never make it. That's an homage to a Green Lantern comic when I was growing up, or Green Arrow, one of those two, Green Arrow. All right. The one that drops straight down. 3, 4.
You're saying which one's gonna take longer?
Which one's gonna hit the ground first?
First?
Yeah, first. I assume the 4 people are still
It's
5, 6.
Yeah.
Let's try that again.
Oh, wait.
I'm seeing hands coming up in rounds here, right?
No.
And be proud. It's okay to be wrong. We're all gonna be wrong plenty of times here. The one that falls straight down is gonna hit first. 1, 2, 3, 4, 5. Ray, you opting against it?
Yeah, no, I'm
All right,
in.
so we got 6.
It's, yeah, it's a distance traveled that you,
The one that's being shot. We got 4. A tie. 2, 3, 4, 5, 6, 7. Neither. I hope not. I hope it's not either.
I didn't bring my flamethrower.
Stabilize this. Now, I'm trying to do it someplace where we actually, if I do it on the table, it's possible that it's gonna miss the table. So we'll try it here. Gotta listen for them hitting the ground. That one hit my foot.
The ball's the same size?
They look at the me.
They're the same size.
All right, so good. My foot's not in the way. All right, here we go. 3, 2, 1.
Same time.
Indeed, it was a tie. Or close enough. So the question is why?
Because your horizontal speed doesn't affect how quickly you accelerate vertically because of gravity?
Exactly. Once it's in the air, the only force acting on it is the force due to gravity,
Once it's in the air.
once it's in the air. Before it gets in the air, obviously one is getting pushed. It has an acceleration in the horizontal direction. But the key thing here is that they hit at the same time. Now, Mythbusters did something where they dropped a bullet and they shot a bullet at the same time. And actually, taking air resistance into account, they still hit close enough to the same time. I was shocked that air resistance did not play a bigger role there.
I'm surprised that isn't the arc path a longer path?
It is, but it's also traveling faster.
Because it had the force shoving it out.
Yep.
Okay.
And that's the offset, and it comes out to be the same.
What was the height that the bullet was being dropped at and the one that was being shot at?
My recollection is it was from about something like this,
Okay.
but
I was gonna say, would air resistance be negligible because they're aerodynamic?
well, because they're aerodynamic, I would have thought air resistance would have had a bigger role. No, that doesn't make sense though. I mean, the point of rifling is because the bullet is spinning, it will stay in the air longer and travel a farther distance.
Yeah.
So that's why I was thinking air resistance would have had a bigger role.
Some of that is to make it fly a straighter path.
So it's just pure straighter path? I thought it would go farther distance too.
Is it at distance? The rifle?
I don't shoot guns, so.
The spin, I don't
I think the point of the spin is to keep the bullet facing the same direction, so that it doesn't end up with the
It
back of the
doesn't
bullet
tumble.
in the pointed direction it's facing, so it doesn't end up like spinning in air.
Okay.
Like, so that the bullet continues in in the same direction it came out,
Yeah,
Right, it's not tumbling, it's
Yeah, it's not
staying
tumbling.
straight.
which would definitely affect how it moved through the air.
All right, back to more practical physics, less practical physics, whatever you want to call it. Back to board physics.
Academic physics perhaps?
So I'm shooting an object this way and I'm dropping it. So in this particular case, I'm gonna make up some numbers. The question is, I throw it from a height of, we'll just say 2 meters. The thing ends up